now that I've given you a quick overview of the executor completion class and the executor completion service class and the completion service interface, let's talk about some of the methods that are in the completion service interface. As you can see, there's not very many of them. There's only 5. And then I'll quickly visualize how these methods are actually used in action, so you can see the flow of asynchronous operation control. So there's just a handful of methods. They all come out of the completion service interface. There's a pair of methods that can be used to submit tasks for execution. Even though these methods both return futures, these futures are never used because we're going to get the results back through a different means via this completion queue we're going to talk about in a second. There is a submit method that submits a task, which, as you probably recall, is a two-way computation, which implements the callable interface and provides an asynchronous future processing model. So it'll be handled through other means than the return value. So in other words, there's no need to block on the future that comes back here. There's also a way to submit a runnable that doesn't return a value. It implements the runnable interface, and we very rarely use that. Much more interesting to do two-way calls because you get the results back. How do you get the results back? Well, there are 3 methods, take and 2 versions of pull. Internally, as we'll see when we get into the internal discussion of this class, there's a blocking queue that's used to keep track of the results as they finish up. And that's what is then feeding the results of take and pull. Take will block until a future for the next completed task has finished is stuck on the completion queue, and then take will return that the result, the future associated with that. What's interesting about this is that what comes back when you get a result back from take is a future, but that future has already completed. So it's done by that point. It wouldn't have shown up on the queue if it wasn't finished. Then there's also a method called pull, and as you can see, pull basically will just return either the next element if there is one ready to go, or returns null if there's nothing on the queue yet. And if you want to wait a little bit longer than just impatiently polling, you can also do a timed poll. So that says, I'll wait for up to some amount of time in order to be able to get the results. So you might say, I'll wait 2 seconds, and if I don't get any results, I'll go off and do something else. So the key thing to note here is that after the future is removed, after you successfully get a future back, that future has already completed, and anytime you call get on it, it will never block because it's already finished. It wouldn't have ended up in the queue otherwise. Okay, so let's take a look at what this actually looks like. This is one of those things, or at least for me, looking at code is actually not the easiest way to understand it. It really helps to kind of see what it's doing under the hood. So here's the big picture view. Clients can use the executor completion service to place tasks into the executor that you associate with the executor completion service, and then under the hood, those tasks are run by threads in a pool of threads. So the high-level view is you have one or more client threads, those are the things you see on the left, submitting tasks to the executor completion service, which is what you see on the right. And inside the executor completion service is a pool of threads to do the computations. And then one or more client threads can wait to get the results back from the thread pool that's running those computations asynchronously. So you might have, a pool of threads submitting work and getting results back and doing stuff with the results. And that would be separate from the pool of threads that's doing the computations inside the executor completion service as part of the executor service. So you could have a pool of threads, you could have one thread, you could have n threads. It kind of depends on how you want to write your client code. So here, a client submits a two-way task. That task gets converted into something called a queuing future and stored in an internal pool of internal blocking queue that then is used to feed the pool of worker threads that run the computations that are queued up internally waiting to go. And that's just executor framework stuff, nothing interesting there. Once the work is done, it's then stuck onto something called the completion queue. The implementation adds the results to the end of the completion queue. And then a client who's blocked on take or polling on poll will get the next result back, or a next result back, and then can do whatever it needs to do the computations on it. So that's kind of how it works if you take a look at this sort of from an operational point of view, from the big picture view. And the cool part about this, as you can see, is you could have a pool of threads generating work to do, a pool of threads doing work, and a pool of threads taking the results and processing them. So in steady state, you could get a lot of computations that could use a lot of cores very effectively and would always keep something interesting happening through the pipeline of computations flowing on the different cores. Okay, so that's kind of an overview of the methods in this